Hey, welcome back. So today we are going to solve Ceil in a sorted array. We are given a sorted array and an integer x. We have to find the index of the smallest element in the array that is greater than or equal to x. This element is called Ceil of x. If such an element does not exist, we will return -1 as the answer. One thing to note here is that in case of multiple occurrences of Ceil of x, we will be returning index of the first occurrence of the Ceil. Okay, so what do we mean? Let's take some examples. Given arrays and the target element is 5. So what is an element which is just greater than or equal to 5? So here it is 8, 8 which exists at index 2. So our answer is 2. Second example, the target element is x 20. So what is an element which is just greater than equal to 20? So as we can see, there are none in the given array. So our answer would be -1. Now the third example, the target element is 0. So what is an element in the given array which is just greater than or equal to 0? So it's definitely 1. But since there are two occurrences of 1, we will be returning 0. That is the first occurrence of 1. So answer here would be 0. Now how we are going to solve this? Let's see. Suppose we have this array. So we can perform a linear scan and keep account of the index of the element which is just greater than the given target element x. So is 1 greater than equal to 0? Yes, it's true. So we would be storing answer as 0. Now coming to the second element which is also 1, so it's also greater than equal to 0. But since we already have got the first occurrence of an element which is just greater than and or equal to 0, so we won't be considering 1 as our answer. We would be returning answer as 0. Okay, but this was a linear scan. Can we do it optimally? If you would have observed carefully, the array is sorted. So we can think of a binary search approach. Let's see how that would work. So again, let's consider the same array and the target 0. We have low pointer and high pointers. Suppose we got mid. So we will check if the mid element is greater than equal to x. Since it's greater than equal to 0, we can consider this as a possible candidate and can store the index of the current mid element. So the index is 2. Since we have an element greater than equal to 0, so there would be elements uh, to the higher search space also greater than or equal to 0. So we need to get the element just greater than equal to the given target. So it won't be feasible to search in the higher search space. So we would move the high pointer to mid -1. Now again we find the mid and we land here. Now is 1 greater than equal to 0? Yes, it is. So we will update answer by 1. So we should continue searching in the lower search space. So we again discard the higher pointer current element and we move here. Now low and high pointers are coinciding and mid will be also at the same position. So the mid element at mid index is 1. So let's check if 1 is greater than equal to 0. Yes, it's also greater than equal to 0. So we would be finally updating the answer to 0, which is the index of the one first occurring one. So since we are not left with any elements, we can safely return answer as 0. So this was it, and uh, we can we have arrived from linear time complexity to logarithmic time complexity. So let's try to code this approach. Let's assign low and high pointers. Also, let's initialize answer initially to -1. Now let's run a loop where low pointer will run until it's less than equal to the high pointer. In the meantime, let's get the mid, which is low plus high by 2. Also, let's try to store the element at the mid. So let's call it current element. Now let's check if the current element is greater than equal to x. If it was, then let's store the index of the current element, which is mid, and let's try to search in the lower search space. So we would be moving high towards low, else we would be moving low towards high. Now let's return the answer and check. So you can see it passed the first test case. Let's also submit our code and check for the remaining test cases. And as you can see, it passed all test cases, and our code was pretty efficient as well. So this was it, and I hope to see you soon.